Hi everyone, welcome to Postgres Google Hangout. Thank you for joining us today. I hope you can hear me okay and see my screen okay. If not, please type in the chat window and let us know. This is Sakshi from Ashnik. With me, I have Mr. Samir Kumar, who is a senior database solution architect with Ashnik. This session will be run by Samir. Now, a little brief about Ashnik. Ashnik is an enterprise open source solution provider based in Singapore with presence across Southeast Asia, India, and the US. We provide Postgres SQL solutions and services across these regions. In today's session, we will cover how to use your favorite Postgres clustering tool in cloud. Over to you, Samir.
Thanks a lot, Sakshi, for the introduction. Let me just quickly share my screen. And yes, all right. So let me begin with the introduction here. Let me just So in this series of Hangouts, we are going to talk about running PostgreSQL in cloud. And as part of that series, in our very first Hangout, we are going to talk about achieving high availability in cloud environment for your Postgres database. We would begin with covering some of the basics of why it is a good idea to run your database in cloud, and then we would go into achieving high availability in Postgres in the cloud. We would also do a short demonstration of how to run Postgres in Amazon RDS. And during the presentation, we will also cover some of the options of running Postgres in cloud. Now let's first talk about why at all you should consider running database in cloud. The very first reason for that is cloud provides you a highly available and reliable infrastructure. The data centers are built with a lot of resiliency. So Amazon Web Services data centers are far more reliable and resilient than most of the enterprises and enterprise environments. They have concept of availability zones to ensure that there is enough redundancy within the region. You can also do cross-region replication, which ensures that a copy of your data gets replicated to another region as well. It also helps you guarantee performance, which is sometimes not that very easy to achieve in your own enterprise environment. You can choose from an array of hardware and storage options and choices. You can go for provisioned IOPS with dedicated SSD disks or provisioned IOPS SSD disks, or you can go for even cheaper storage as per your requirement. It also provides you different options when it comes to choosing CPU and RAM. You can also scale your environment or your setup horizontally or vertically as you grow. Of course, the choice of scaling, whether it is horizontal or vertical, will depend to quite an extent on the architecture that you have gone with, on the cloud database service that you have opted for. You also have better security of the data center itself. So the data that is residing in cloud is quite secure, as in it is stored inside encrypted disk. It is the physical access and the network access itself are quite secured. You have network and physical isolation as well, so that no one can actually reach out to the data center. All those measures for securing the data center access are ensured by cloud providers like AWS. You also have options of virtual private cloud and having direct line to your data center for more reliable and more secure connectivity. You, of course, can achieve much better operational efficiency when running your database operations in cloud. You can have inbuilt monitoring. You have automated backup and recovery, which makes a lot of tasks for easy for the DBAs. You can now, with your team of DBAs, you will be able to handle much larger database footprints, and at the same time your DBAs will be able to invest their time in much productive tasks, in tasks which requires their inputs, for example in application SQL tuning, or in providing inputs back to the application about which kind of tables should be cached, or in providing inputs to the application on designing certain table or entities or schema, or adding indexes. These are the tasks where you can use the time of your DBA, because you have been able to free them up from taking backups, or doing recovery or testing backups, or, or setting up environments. Now let us come to our today's agenda, where we would be talking about how to achieve high availability in cloud for your Postgres database. There are multiple different Postgres database options in cloud. If AWS is a platform that you would want to choose, you have Amazon Web Services relational database service, which you might have heard as AWS RDS. It has Postgres option. AWS has also launched quite recently Aurora, which also has Postgres compliant database service. Then Enterprise DB, one of the largest vendors of Postgres, also provides a cloud database service in AWS. It is called as Postgres Plus Cloud Database. EDB also provides PPCD, or Postgres Plus Cloud Database, in various other different platforms like Google Cloud. EDB has also recently launched its support for platform as a service uh, infrastructures like Cloud Foundry. It also provides you. It has also come up with a tool known as EDB Arc, which is going to make orchestration of database on such PaaS and public cloud platforms much more easier. And of course, you can also run your database on a virtual machine in cloud, which means that if we talk about AWS, you can also spin off a virtual machine from EC2 console and install Postgres Plus or Postgres SQL on that, and run it as if you're running it in your own data center. Of course, that approach has its own advantages and its own pros and cons. It though ensures that you don't have to worry too much about hardware and infrastructure provisioning, but at the same time your DBA still ends up doing the installations and maintaining and managing those databases and their backup recovery and those aspects. But yes, of course, it provides you with much granular control on the environment and the database itself. Now, what are your high availability options when you're running? Let's talk about specifically AWS. You have capability of deploying your database service as a multi-AZ deployment. AZ stands for availability zone. In Amazon, you have concept of these availability zones, which are there per region. So in every region, there can be two or more availability zones. And think of these availability zones like data centers, though there could be multiple data centers which make up one particular availability zone. But think of them as data centers which are separated by a very low latency network. So you can use that for achieving redundancy within a region. For example, in Singapore region, there are 2 availability zones. And whenever I set up a cloud environment for a customer, I would actually choose a replica database to be created in the second availability zone. So that is how you can achieve some level of redundancy. The replication from first availability zone to second availability zone is actually a synchronous replication, and that ensures that your data loss is actually zero. And if your server fails in the first availability zone, it is automatically brought up in the second availability zone without hampering connectivity to the application. You can also create asynchronous read replicas for RDS, and that is just a matter of few clicks. And you can choose that replica to be present in any region. It can be in the same region where you are hosting your your uh, your primary database, but you can also choose it to be to be another region. When we do the demo, we will see how to set up a replica. You can also choose, like I mentioned, EDB Postgres plus cloud database, and that also provides you options of multi-AZ replication. It allows you to choose multiple replicas when you're initially starting off the instance. You can scale up the number of replicas on demand. It also has automated cluster manager which monitors the health of the setup. It has auto healing capabilities, so if your master database goes down, it replaces that master with a new instance. And the health of your replicas and the master, everything is maintained. Your cluster overall is will still be available even when your master goes down. You can also set up uh, Postgres on a virtual machine, like we discussed, on an EC2 virtual machine in Amazon Cloud. And to achieve high availability, you can use streaming replication to have redundancy of the system. You can use clustered storage. You can use multi-AZ replication there as well. That again would be a uh, storage level mirroring that you can use along with EBS. Now, once you have talked about, so far what we have talked about is how to have redundancy in the environment, in a cloud environment. Now, second aspect of high availability is ensuring that any kind of failover is masked from the application. Application does not or should not get impacted whenever there is a failover. If the machine or EC2 machine, or if the database instance goes down for some reason, that should not have an impact on the on the availability of database services to the application, and it should be very much transparent to the application. Now, that can be achieved by automated failover among availability zones or regions. You can use virtual IP, or in terms of Amazon, you can use public IP that allows you to route traffic to a specific machine. That becomes like a static public IP of your machine. You can also use query routers or load balancers. For example, pgpool is one such tool. It is used by EDB in its own Postgres plus cloud database solution that allows you to set up the whole query routing, and that makes all the failover and load balancing transparent to your application. You can also use a clustering tool, especially when you are installing in your own virtual machine, you will be required to use some clustering tool like failover manager from enterprise DB, or you can use PG pool as well, which can do some kind of failover command whenever there is a issue detected in terms of connectivity to the master database. The failover configuration differs vastly in the cloud environment as compared to the on-premise environments. The, the, the main reason for that is the failover configuration or the transparent failovers are to quite a large extent dependent on virtual IP. Most of the architectures achieve that by using a virtual IP. Now, in cloud infrastructure, public IP or the IP which is used for reaching out to your machine or your AWS instance is actually never physically attached to that virtual machine. It is kind of a NAT or a routing entry somewhere in at the network layer, which knows that any inputs coming to a particular IP address should be routed to some virtual machine or to some EC2 instance. And in case of RDS, you actually cannot do an installation on the on the uh, on the machine hosting your database, because RDS does not allow any kind of shell access. So these are two primary differences when you have to talk about how your infrastructure and the cloud infrastructure would differ. Of course, the health check mechanisms in terms of getting the health of a particular node also differs. Now let's look at how you can still achieve failovers, or how you can still do transparent failovers, and what configuration and tools can help you. AWS CLI is a tool which DBAs should be familiar with when when they're running their database in cloud. It allows you to access a lot of commands or perform a lot of operations. For example, it allows you to do promotion of read replica, or it allows you to move a virtual IP to from one machine to another machine. Uh, that is basically releasing the virtual IP or elastic IP and then attaching it again. It also allows you to monitor the health of the cluster from your command line. Now let us take a look at that. So I'm going to show you that. So over here I have an example of AWS CLI. Let me get to the right command. So here is AWS CLI help. It allows you to interact with different AWS services. The ones which are listed in the beginning are CloudWatch, ACP, and you know, TMS, EC2. Now let me just go to RDS. So here is RDS service. So you can use AWS CLI to interact with your RDS environment or the RDS instances in your environment, in your cloud environment. There are different commands which are available. You have ability to create parameter group. You can, the most important ones are, or the basic ones are, creating a DB instance or creating a replica of the DB instance. You will also have ability to create delete the DB instance, or describe a particular instance, or describe events, or fail over a particular cluster that is not applicable to Postgres, by the way. You can You can promote read replicas. So when you want to promote a particular read replica, you can use this command, and that can be done from the command line tools. And that means that you can actually embed these commands in your shell. You can embed these AWS CLI commands in your own shell script, and that can be used along with your failover tools. For example, in pgpool, there is an option to fire a particular command upon every failover. That command could be promote read replica command. There is or it could also encapsulate destroy the DB instance or delete DB instance, so that it cleanly removes the DB instance, and after that it comes back and promotes the replica instance. There are also similar options available in EDB failover manager, which allows you to have a fence script and post promotion script that can be used either to promote a particular Postgres instance running on EC2 virtual machine, or it can also be used to switch the virtual IP or the public IP, or in terms of AWS jargon, we call it elastic IP. You can move the elastic IP and reattach it to the standby which is being promoted. Now let us go to AWS demo that I've been talking about. So this is where I am going to go to the AWS demo. You can go to AWS RDS Console by going to aws.amazon.com/RDS. The link will be embedded in the PPT as well, so you can use that to navigate to this location. You need to sign into the console. So I clicked on the sign in console button on the right top hand side. I'm already signed in. Now, if you're not already signed in, this is a screen that you will see. Let me just repeat that step one more time, so that, yeah. So on the right hand side top corner, there is a sign in button that will take me to the console login, and I'm going to log in to my account now. So I'm going to go to RDS here, over here. So these are different AWS services which are available to me for my account. The ones which I have been mostly using is EC2 and RDS. So let me go to RDS. And then you just need to go to instances over here in the left hand side panel. And you can quickly launch a DB instance. Choose your DB instance PostgreSQL type. So the engine is PostgreSQL. That is the engine we want to use. Let's select that. And here you have two different options, where you have one option is with AZ deployment and provisioned IOPS. The second option is more for development or testing environments. I'm going to go with the first option because multi-AZ deployment is one of the most important aspects when you're deploying in production. So let's go to next step. Now here, you can choose what is the version of Postgres that you want to deploy. I'm going to deploy 9.6 here. And you can select the machine size that you want to deploy. I'm going to choose T2 micro. Do you want this to be a multi-AZ deployment? Yes, this needs to be a multi-AZ deployment. You can use either general purpose SSD or provisioned IOPS SSD. Of course, provisioned IOPS is going to be more costly option, but at the same time, it will guarantee performance. The allocation for storage can only be in blocks of 100 GB, I believe, and the IOPS should always be in blocks of 1000, and this should always be in a ratio of 1:10 to provide the best performance. So I'm gonna choose actually general purpose SSD, and I'm gonna go with 20 GB of data. I'm going to provide an identifier here. So I'm going to say AWS RDS demo. I'm going to use master username Ashnik, and I'm going to use a password here. Go to next step. It's saving this. I'm using VPC, so this actually shows me VPC configuration. And I want this to be publicly accessible. So I'm going to use EC2 user, VPC security group. Security group basically contains the rules for incoming connections. It is kind of a firewall rule, though not exactly a firewall kind of setting, but it basically enables you to configure connectivity or accept connectivity. I'm going to give a database name here. So I'm going to say Ashnik DevDB. I can use any port here, and I personally would suggest using a different port number than 5432. It ensures that you have some layer of obfuscation incorporated in your choice of port as well. Now here comes the choice of parameter groups. We will come to this later on, but for now just notice that I'm using default parameter group. And here comes the interesting part where you can where you can just specify the backup retention period and what is the window when you want to take backups, and based on that backups will be taken. So I'm going to specify that take a backup at 2 a.m. UTC time. Don't spend more than 1.5 hours on doing that. And then I can also specify monitoring parameters here. I can do monitoring, I can enable monitoring, and I can also say that automatically apply patches on a Saturday at 4 p.m. UTC, which means 12 midnight Singapore time. So I'm actually choosing this to be on the midnight of Saturday. And don't spend more than an hour on this. Actually, it should be much faster than that. It doesn't take much time. The patching in PostgreSQL, it does not take too much time. So I'm going to say now launch DB. This will launch a new database. I have some issue here in the DB name, so I'm going to change that. I'm going to say launch DB. I cannot use hyphen. Now my instance is being created. So let us go to my RDS page, and you'll see that there is a PostgreSQL instance that is getting created right now. Wait for this to get created. In the meanwhile, let me show you parameter groups. Parameter groups is a place where you can define parameter settings. These settings will be applied to a new Postgres instance when you start an RDS or RDS. Let me create a copy of this parameter. Okay, so let me just create a copy of new parameter group, which is 9.6, and I'm going to say create. Sorry. 9.5 dot sorry 9.6 dot demo. This was created for Hangout demo. So a quick description, and then I'm going to say create. Just create this. Okay. All right. I believe I cannot use dot in the name. I just need to be it next time when I'm doing it. Anyways, here is my parameter group. Create these parameters. Right now they have been configured with the default values. Now all those Postgres parameters are provided here, and you can go and modify that. For example, let's say I want to keep my checkpoint completion target to be 0.7. I feel 0.9 is a little too aggressive. There are all the other option parameters as well, which you can go and modify from here. There are some RDS specific parameters. Let me take you to them over here, so you can specify some of the RDS related parameters as well, like what is the log retention period. Do you want to force the SSL? Do you want to keep logging? What level of logging you want for admin? Then there are memory parameters, like what would be there, and you will notice that here memory parameters will contain this special parameter or a placeholder, DB instance class memory, and this gets replaced with the amount of memory that is allocated for the class of instance. In our case, we have chosen T2 micro, so this will get replaced with the amount of memory which usually gets allocated to T2 micro, which is I think 1 GB. It gets replaced in bytes, and this is the multiplier factor, or the factor which they multiply or divide with to arrive at the right value. Now similarly, you can use this parameter in other or this variable DB instance class memory in other parameters as well, which includes the effective cache size, or in buffer or work mem as well. So let's just commit these changes. So I'm going to save these changes. This ensures that this is a generic parameter file, and even if I have a server with 1 GB memory or a server with 16 GB memory, I can use the same file, because most of my memory parameters will be decided on the fly based on the instance memory. So this is quite useful. Let me go to instances now. The instance is almost ready right now, and I cannot do anything right now because it is still getting ready. Now while this instance is getting created, let's come and look at one more mechanism which can be used by you for creating the instance, which is create instance command. You can use create db instance command from the command line to create an instance, and that has different options, which all the options that we explored a while ago are available here as well in terms of security groups, master username, password, port number, whether you want multi-AZ or not, IOPS allocation, storage allocation, the type of storage that you want to go with, all that option is available here. Now what I'm going to do is I'm actually going to fire a command which I have pre-populated so that I don't end up spend too much time typing that command. Now here I'm creating a DB instance of T2 micro size. The name of that instance is going to be RDS Hangout, and it will be set up with multi-AZ support. I'm using Postgres engine. This is the very first choice that I had made, if you remember. The engine version is 9.6.1, and the database username is going to be pguser with password ashnik123, and I have used default parameter group here. Now let me go and check what is the name of the parameter group I have just created. I created Hangout 96, so let me just copy Hangout 96 here. So I've got this new parameter group for this new instance that I'll be creating. And once I press instance enter, it will start creating that new instance over here. Now this is an output that I have got, which provides me with different details of this instance being created. It has got created in Southeast Asia region, and it should be showing here in a while. Now you can see that I have got second instance in this scenario, Postgres RDS Hangout. That is the one which I just fired from here, from my command line. And I can similarly create a replica from here, or I can promote a replica from the command line. Now let us let's wait for this to be modified. It will take a little while. It takes a little while for this to get modified. In the meanwhile, let us try to create a read replica for this instance. And while creating a read replica, I can choose a different instance size, though I would recommend very strongly that do not choose a different size of the instance for your read replicas. And even the storage configuration, try to keep it as similar as possible. So I'm gonna choose a different region here. So here I'm going to choose Sydney as a region, not Singapore. So I'm creating a read replica in Sydney region. And actually I don't have any subnet created. Now, as you notice, in Sydney actually there are 3 different availability zones available. So I'm going to use 2A. I'm going to keep the same database port as well. Create the read replica. I still don't have my instance ready. It seems it is still being modified. So until it is available, it is completed, I cannot do this. So let's just wait for that to be completed. Similarly, there is also a marketplace where you can get. Now this was about RDS instance, which you can set up automatically, but there is also a marketplace from Amazon, and in that marketplace you can look for Postgres plus cloud database. To go to that marketplace, you can go to aws.amazon.com/marketplace, and you can search for Postgres Plus Cloud Database. It will show you different options that are available. There is Postgres Plus Cloud Database Advanced, which is actually Enterprise DB's Postgres Advanced Server running in AWS. And there is Postgres Plus Cloud Database Basic, which is actually Postgres SQL running in AWS. And this also provides you shell access. Now remember that in RDS, you do not have any shell access. You cannot access that machine. And that means that there are a lot of administrative tasks that you will not be able to perform, but at the same time, you also don't need to perform those tasks. Whereas with AWS instance or EC2 marketplace, you can actually launch EDB instances, and these will have all kind of access that you want. So this is actually pretty straightforward. You can go here, click on any of them. PV and HVM basically are two different mechanisms for virtualization, so you don't need to worry too much about it. I think HVM is what I'm going to choose right now. The DBA, you might just need to consult with your cloud infra team, and they will advise you which is the right instance for your environment or for your kind of applications, or what has been standardized for your enterprise. And I'm gonna now go up, and I'm going to actually launch an instance from here. I'm gonna show you just a minute. Okay, let me press continue. Once I press continue, I can select a particular region. I'm gonna select Singapore, and I can choose the version from here. I'm gonna choose 9.5.5. Looks like a stable version. Yeah. And then I can choose launch from here. I need to launch the EC2 from specific region. So I'm going to launch that. This will actually launch a new EC2 machine, which has Postgres pre-installed on that. Now, if you want to orchestrate a cluster of Postgres, which has masters and multiple slaves, which is running along with PG pool, for that, you need to actually go to theclouddatabase.com with for AWS with a specific region being provided, and you need to register your user, and after that you need to follow some instructions to ensure that that user can create AWS instances. You need to use IAM console to create a new user and add several policies, and the few of the other settings needs to be changed for that user, so that that user can be used by AWS or rather EDB's cloud console to launch instances. That will provide you with a very nice user-friendly. You can launch instances with replicas, configure backups, and you will have shell access to all these instances. So that is something which I would recommend that you guys try on your own. There is a link in my PPT. You can follow this link and you can explore that at your end. Let me just quickly go back to my RDS instance and check if my RDS has been. It is still not started. It is being backed up right now, and I don't think even during backup I'll be able to create this replica. Let me just quickly try. Yeah, I cannot do that. So it is gonna take a while now. So in the meanwhile, let me go back here, and let me check if there are any queries over here. No, you cannot have. So the question is, can I have a streaming replica from RDS to my own data center? You cannot have that. AWS does not allow that. It is not supported right now. But yes, what you can do is you can use AWS's DMS service, which allows you to do data migration and replication setup from RDS instances. Or if you're so particular about that you want to have a physical replica in your data center and another machine running in AWS, in that scenario, actually what you need to look at is using your own machine, or installing Postgres SQL or EDB Postgres on an EC2 machine and using a similar machine in your data center. So that is what you will have to do if you want to set up your own replication. Yeah. Okay. So second query is, what is the kind of replication which works between availability zones? Uh, the replication specifically in case of PostgreSQL, it is actually a storage-based replication, and it is synchronous in nature. It it can it is there to ensure that you have RPO0, so it is pretty much synchronous. It ensures that any commits happening in the primary data center or the primary availability zone also gets replicated immediately to the secondary availability zone as well. All right. Okay, this is an interesting question. What would you recommend, EC2 or RDS? Yeah. Okay. So you know, RDS is something which abstracts a lot of implementation details from the uh, developers and DBAs. It helps them focus more on the tuning, SQL tuning, and schema tuning and schema designing part, while abstracting a lot of monitoring and management overheads from them. But at the same time, it gives them very little control over the database and a lot of administrative tasks that sometimes DBAs want to control. Whereas when you are looking at something like EDB's PPCD, I think it brings best out of both worlds, while it offers you all the automation and in terms of backup recovery and auto healing, auto scaling kind of things, and it also very much automates the deployment of your instance and creating a new instance. But at the same time, it also allows you to have some control, some shell access. So that is actually pretty good balance between both the worlds. Whereas installing Postgres on an EC2 environment is on an extreme other end, where you have to actually install Postgres on an EC2 machine, just like you would be doing on a virtual or physical infra in your own data center. So while that gives you a lot of control, it of course adds some overheads of traditional data centers to the DBAs. It's very much the conventional way in which deployments would be done. Let us go back to our console and check if this environment has been set up or not. Okay, so it is now in available status. So what I'm going to do is I'm going to now create a read replica. So it is I think I have missed something. Yeah. So this is, I'm going to call it RDS Hangout demo replica. So this is my DB identifier, instance identifier. That is how Amazon or AWS will actually recognize that particular instance, and it will be listed over here. Over here. Now you will soon see that a replica is getting created. To create that replica, there are some modifications which will happen in my current instance, and that is why you see that status has changed from available to modifying. And it will take a while. When you're running in EC2 or you're running an RDS instance, you can actually purchase a reserved instance that that kind of gives you a little better pricing, as actually quite good savings as compared with on-demand instances or on-demand RDS setup. So that was about it. That was about demo as well. Thanks a lot for joining us. Thanks a lot for your questions. Do write to us with your suggestions, and if you have any more questions about using uh, Postgres in a cloud environment, please write to us at success@ashnik.com. Follow our social media feeds on Facebook, Twitter, Google YouTube, by Ashnik Biz handle. You can visit our website and and subscribe to our newsletters to get continuous updates on our on our events and about our services. If you are interested in having a discussion on architecture or what benefits Postgres on cloud can bring to you, please feel free to write to us. Also, let us know your suggestions on what you would like to hear in the next Hangout in this series. Do you want to hear about securing database in cloud, or do you want to hear about monitoring database in cloud? What is it that is of more importance to you, that interests you the most? And we will try to pick up our next topic accordingly. Thanks a lot. Thank you very much for joining us.